So now that we have taken some time and whiteboarded the concept of level, in this video Logan is going to create the level class, implementing everything that you saw over on the whiteboard.
Alright, well let's get started. We're going to go down to the game folder and we'll add our new item. This item is going to be the level file. First thing we'll do is clean up the sub namespace, and before we get started I would like to drop in a using for XNA.framework. Now that we have these types available, we can turn our attention to everything that the level needs. We're actually going to begin with two additional types that we'll define before the class itself. We had mentioned on the whiteboard that we need to be able to store the type of each record that we're going to put into this list. And opposed to using just a textual name, I'd like to have something, a solid reference to point to what kinds of things go in this record. So we're going to use an enumeration. Let's go ahead and drop that in, and then we can move on to the definition of the record struct itself. The enumeration, though, is going to be called item type. And at the moment, there are only two types of things we can put into levels, and those are asteroids and enemy interceptors. So we'll put two elements into this enumeration. Asteroid.
Oh, two T's managed to sneak by.
All right. With some spelling, we've got asteroid, and we're also going to put in enemy interceptor.
You know, you've had no trouble whatsoever spelling out enemy interceptor, yet I can't even say it.
I think it's just the letters are different enough. I don't know, maybe it's got a good consonant, vowel, consonant rhythm going throughout.
Maybe so. Just doesn't work for me. Okay. Next, let's go ahead and get that struct in place for the level item.
Right, and once again, this is simply the struct that defines what you would describe as a record on the whiteboard. This is going to save all of the specific pieces of information that go along with each item, such as time, type, position X, speed, and direction. So putting this into place, we're going to make a struct. The struct will be called level item. So a single level item will consist of the following. All these fields will be made public just so we can use this thing as just a purely data-based item object, if you will. The first field, the time field, is going to be of type double, and it's simply going to be called time. After time, we have the type. This is also going to be public, and this will be of type item type, and the name will be type. After that, we've got our position X. That will be a floating point value called position X.
Almost.
Almost.
Perfect.
After the positioning, we need to have the speed of the item. So this will also be a floating point value, and it will be called speed. The final field will be a vector 2 to describe the direction in which this item should be moving. And that is all of the pieces of information we wish to store in our level item struct. Now we can finally turn our attention down to the level itself. The very first thing we'll do is we'll set level to be static. And we'll simply require that all members inside themselves be static, because the idea of level is this: instead of being the physical thing we see, this is the containing point, the organizational level that contains everything level related.
That's right.
If you want to think of the level as an actual thing, that thing is going to be the level items list that we're going to be creating shortly, if you want to look at one specific thing that actually exists.
Speaking of which,
well, we have some fields we need to drop into level, the first of which is that level items list. It will, of course, be static. The type is going to be a list. The list is going to be of type level item. And the name for this will simply be level items. Now we'll also turn around and instantiate the list itself, though we will, of course, leave it empty until we actually get around to the instructions which build levels. Alright, two more values that we need to drop down. This one was mentioned at the end of the whiteboard lesson, and it is the time cursor. It will be of type double. Again, the type here being to match the type that time itself is stored in. And the name of this is the time cursor. And just as we had said on the whiteboard, this is our helper to remember where we are at in time as we're assembling a series of level creation instructions. The final field that we're going to need is, of course, once again going to be static. This field is our item index. And this is the field that saves our current position within the level items list as time advances. This is what allows us to restart at a specific point in the middle of a level instead of having to go all the way back to the beginning of the level to reconsider things. And as a matter of fact, if we went all the way back to the beginning, we would cause every item to continuously spawn since its spawn time.
Guys, I'll have to see if I can get Logan to do that. It's pretty neat looking.
And does create a rather interesting cascade effect. Now, one final thing we'll do to both of these is our code is going to rely on both of them starting at a value of 0. So even though they will by default initialize to 0, I'm explicitly going to initialize them here just so that it makes it blatantly obvious the fact that, okay, our values are starting at 0. Item index is starting at the very beginning of our items list. Time begins at 0. And then we can offset later in time accordingly. All right, now we're ready for some functionality. But before I put the meat of each of these methods in place, I'm actually going to skeleton each of them in. And this will, of course, just ease implementation as we don't have to worry about interdependency. So beginning at the top, we're going to start with the build level method. It will be public, and of course it will be static. The return type will be void, and the method name is build level. And once again, this is the method that will contain all of our level assembly instructions and will be called at the very beginning of the game. Moving on from here, we have our add item method. It will be static, have a void return type, and is called add item. Now we need to take in a series of parameters that can be used to describe a level item. That means we're going to need to take in time, position, speed, and direction. We are not going to take in time as a parameter because add item is going to be set to automatically use whatever the current time cursor is and save that value into time into the new level item that it is creating. So the first thing that we do want to focus on is item type. We'll take this in as a parameter called type. From here we need position x, which is a float. Next we have speed, which is also a float. And finally we have direction, which is a vector 2. Alright, now in addition to add item, we have one overload, and that allows us to make an add item call without having to specify a direction, which means inside of the instruction we'll simply default the direction to be in the down direction. So once again, static, void, add item. Now in order to speed the creation of this method signature, I'm going to copy all except the direction parameter from the previous add item method, put that into place. That gives us our signature, and now we can move on to the final methods. Now we need to address the update method. This method will be public. It will be static and have a void return type. Also, update is going to be need to be given a game time data. That is a game time parameter. Alright, finally we have the spawn item method, the method that is responsible for turning level items into actual game node objects. It will be static, have a void return type, and will be called spawn item. Spawn item needs to take in a level item to spawn. Alright, that takes care of our method skeleton. Let's go back up to the first add item method and begin our implementation. Now add item needs to assemble an actual level item out of all of these parameters. This level item is going to begin life as a simple local variable, but that local variable will be later added to the list in order to maintain it after this method call has finished. So we'll define that we're going to have our level item. We'll simply call the local variable item, and then we can begin setting this item up. We'll go straight down through all of its fields beginning with time. So that means the item's time is going to be set to whatever the current time cursor is set to. Moving on from here, the item's type is going to be the given type parameter. The item's position in X is, of course, going to be the position X field. The speed is going to be the given speed. And finally, the item's direction is going to be the given direction. So once again, just assemble all of the parameters into a level item. Now that we have set up a level item, let's add that into the level items list. So make a call to level items.add and add in the specific item. Alright, now we can move on to our alternate or our overload of add item. And all we're going to do in here is make a call to the first add item. The only difference is we're going to specify default for direction. So that call to add item is going to consist of passing through all of these parameters and then making up a direction. That means it's going to pass in type, it's going to pass in position X, it's going to pass in speed, and direction is going to be a new vector 2 in the down direction, which is 0 in X and 1 in Y. That finishes off the vector 2. One more parenthesis finishes off the call to add item, and that takes care of our add item overload. Alright, now that brings us to the very heart of the level class, and that is the code which allows each update in our game tick, or excuse me, each game tick in our update to look through the level items and see if there are any items that are due for spawning, if their time to spawn has come up yet. And this walking through the list is going to be accomplished using a loop. I'm going to make a for loop, but I'm actually not going to use the code template this time because I wish to change the value that the index variable begins at. Our index variable is going to be an integer, I. Instead of starting at 0, so instead of starting at the beginning of the list, it's going to start at our item index. This gives us the ability to, in each update or in subsequent updates, change the place at which the loop begins at within the list. Now we're going to continue looping as long as I is less than the number of items. Basically, we're going to continue looping until we reach the end of the items. So until while I is less than items.count. And then, of course, for each iteration of the loop, we will increment the index variable. Now, as we're looping through item by item, the first thing that we need to check for each item is to see when we have hit items that are spawning in the future. Because at this, let's say we have spawned through just a number of steps into the items list. If any of the items we have come across were less than the current game time, if their time was less than now, they were in the past and they're due for spawning. As a matter of fact, if we're looking at them, then they're technically a little bit late, so everything that is late or exactly equal to the current time needs to be spawned. If, as we're looping through, we come across an item whose time is greater than the current time, that means his spawn time is in the future. He's not ready to spawn yet. And since we're going to basically just set up our levels with a rule that we always have to advance, time always has to advance in a forward fashion, that means the moment we find one item that is in the future, we're going to assume that all of the other items are also in the future, and that means there's no reason to finish looping to the end of items. We can just break out of the loop, and we'll hit those items at a later time when game time may have advanced enough to need to worry about spawning them. The if statement that is going to check this for us is going to look like the following. It's going to check the current level item. That means it's going to get level items sub I. And it's going to check to see if its time is greater than the current time, basically the current second stamp of right now. That value is given by gametime.total seconds. So the moment we found a level item that needs to be in the future, that means we're done looking through items. We're going to assume that every other item is also in the future, and we'll get to them at a later time. That means we're done looping, we'll break out of the loop, and then that's it for this walk through level items. If, however, we made this check and found that the current item that we're looking at is not in the future, that must mean it was to be spawned now or in the past. And if it's past, again, it's just a few game ticks late, technically because the time itself did not fall on an exact game tick. But if we have gotten here, that means it is now time to spawn the item in question. That is going to be accomplished with a call to spawn item. Spawn item needs to take in what item we're about to instantiate. And now I say instantiate loosely because obviously we don't directly instantiate level items. We use the information in level items to instantiate game nodes. But once again, the item being passed to spawn item is the current level item. That is level items sub I. Now that we have spawned this item, we need to advance our item index to indicate that we are now past this item and never need to reconsider it for spawning. And we'll do this by incrementing item index. And once again, this item index now marks us, meaning if this was the last iteration of the loop, and then we later reran the loop, we would now remember that, we need to start at item index, not at the beginning of the list. Alright, now we can implement spawn item. Inside of spawn item, everything is going to revolve around the creation of some type of game node. So I'm going to begin with a local variable of game node. So we can start general and then begin describing exactly what this node should be like. I'm going to make a local variable called node, and I'm going to initialize that variable to null. Now, from here, the next thing we need to do is to look at our incoming item and to check its type, and depending on that type, we need to spawn an array or an assortment of different game nodes. Basically, depending on the type, we might spawn an asteroid or an enemy interceptor. And this is you could almost call it a conversion between what is essentially our made-up item type enumeration and an actual instance of a specific game node. The way we'll do this is with a very simple if-else series of conditions. And the syntax will go something like the following. We're going to start an if statement, and that's going to check the current item's type. And it's actually going to be looking for a very specific type. Let's say that this first check is to see if the type is item type.asteroid. Well, if this comes up, that means that we now need to spawn an asteroid. That means we're going to take node, and into node we're going to store a new instance of asteroid. That asteroid is going to need a sprite sheet, and we'll give it the standard asteroid sprite sheet. So we'll look into config and give an asteroid sprite sheet. Now, if the item type was not an asteroid, maybe it was an enemy interceptor. So we're going to add an else if. As a matter of fact, the else if is going to do the same check, except that it's going to be looking for enemy interceptor and do essentially the same spawning code. So I'm actually going to copy and duplicate that line and change the second if to an else if. Because if we didn't find an asteroid, we need to check the other possibility, which is an enemy interceptor. If that was indeed the case, we're spawning a new enemy interceptor, and we need to pass along the sprite sheet for enemy. And that takes care of the logic necessary to translate an item type into an actual instance of a game node. Now, we have some parameters left. If you remember, level items have things like position in X, how fast they're going, which way they're going. So we need to make sure that that information is carried on and assigned to our brand new node. Now, we also have to be a little bit careful here, because looking at this if-else block, there is, of course, the possibility that if we did not find a desired item type, we may end up with a null game node. So we want to make sure that we don't attempt to set settings on something that doesn't exist. So we'll first do a check and make sure that node is not equal to null. If it's not null, that means we have a game node and we can proceed with the final stage of setup. The first thing we're going to do is to set that node's position. Now this is just a little bit interesting because we don't have full position information in item, we have position in X. Position in Y needs to be set so that the node in question is just off screen, ready to scroll on screen smoothly. So that's going to involve using the stored position X value from the item, and then we'll calculate based on our sprite's origin to move it just far enough the screen in Y to be off screen. So looking to our node, that is going to be a setting of node.position to a new vector2, where we can specify separate values for X and Y. The Y value is going to use the value of the items position X. The value in Y is going to need to be off-screen or negative in the sprite origins Y. So it'll be negative node.sprite.origin.y. Alright, moving on from position, the only two things left are speed and direction, and those can be obtained directly from item. So that is node.speed equals item.speed. And finally, node.direction equals item.direction. And with that, that is all of the code that is going to be part of spawn item. Before we leave this method, though, there's one final tweak I'm going to do to the if-else logic, and that is I'm actually going to compact the code a little bit and do each check on a single line. Now, even though that makes the code a little bit harder to read as we now have to scroll, the reason behind doing this is later in time, if we begin creating more types of game nodes and more types to go along with them, we have to add some code to handle each new type into spawn item. It has to be aware of all of these new types. And establishing these on single lines makes it easier to extend this method. Let's say, for example, item type now held a new kind of enemy, and we had a new kind of enemy class to spawn. Let's just for theoretical purposes say we made a blue enemy. If we wish to add support for a blue enemy, the procedure would simply involve duplicating whatever the last else if is, changing the item type to blue enemy, making a new instance of blue enemy, and giving the appropriate sprite sheet for blue enemy.
And of course, let's not forget we need to add it into the enumeration as well.
That's correct, because saying that item type was equal to blue enemy, where would that come from? That is all based in the available item types, so we would need to add an extra item type for that specific item. But once again, that's the reasoning behind putting these lines, this code on single lines, as it makes extending later a little bit easier. Alright, now we are approaching the point at which we can begin assembling a first test level. And again, assembling a level is all going to result in add item calls instead of build level. Before I put in this simple level, which is going to consist of one item, I would like to establish a property which gives us easy access to the screen center, because at the moment we have the screen width, but we have to divide that in half in order to get the screen center. And typing out the expression config.screenWidth divided by 2 gets repetitive if we need a lot of items centered on the screen. So I'm going to make a static integer property called viewCenter, and it is going to have a getAccessor, and that getAccessor will contain the necessary expression for finding the center of the screen. It will return the value config.screenWidth divided by 2, then we'll specify a curly brace to end the getAccessor, one more curly brace ends the property. Now we have very easy access to viewCenter. Alright, now time to put a very simple level together so we can test out our level system. Alright, let's see how simple we can make this. We know we're going to need calls to add item. To put a call together, we're going to need to begin with item type. Let's begin by making an asteroid. The position, well, let's put it on the center of the screen. Let's leverage our viewCenter property. And for speed, let's start it off at a value of 2. Alright, that's all we need for the most simplistic level. Remember that time cursor is automatically starting out at 0, so there will be no time delay before this instruction is executed.
We start the game and an asteroid smoothly scrolls into the viewable area.
Exactly.
But now, not yet, because we haven't tied it all together yet.
That's right. All of this stuff is all well and good on its own, but it doesn't do anything until it's invoked from outside in the game class. So what do we need to do to finish tying this together? Well, inside of game, there are 2 calls we need to make. The first call is we need to make sure that level is updated periodically inside of the update method, and we also need to make sure that a call is made to begin level at some point.
Or to build level.
To build level.
Yep.
To make sure that these calls are in fact executed. So let's take a look at that. First, let's go down to update. We'll jump in right below we have done all of our dead node removal, and we'll make a call into level, and we'll call update. And of course, update is going to require the current game time. And that really takes care of that. That one call is what in turn allows us to progress through our level items and play them back over time. Now to get everything kicked off, we're going to go back up a little bit into begin run. Now that we're getting very close to having level functionality, I'm actually going to wipe out our temporary code that was creating asteroids and an enemy for us. We'll simply delete that out, back up a line or two, and we'll put in our call to level.build level. Alright, let's build the project and then test it out. We see immediately upon spawning an asteroid smoothly scrolls from just off the top of the screen. So that's a success. Our basic level is working.
And you can quickly jump in there and do something like take that center position and add 100 to it.
Alright, so by adding 100 we should be offsetting to the right of the center of the screen. If we test this, that is in fact the case.
Very
now
nice.
The asteroid is actually far enough to the right that it misses the ship.
Alright, now let's just simply change the type from asteroid over to an enemy interceptor.
Alright, looking here at item type, well, what else do we have? Well, we have the other type, which is enemy interceptor.
Hey.
He's an enemy now. So this is getting, even for testing purposes, this is making things much easier because now we don't have that big block of code handling every single thing. We have everything compressed down into what is relevant item by item.
Now let's add a few add items in there, utilizing our time cursor so that we can test out timing.
Right, we need to make sure that we can make different segments and have time, or have our ship advance through them through time. Alright, let's make a few of these. I'll simply copy and paste a few times to get 3 add items. Let us drop down after the first add item. Let's take our time cursor and let's advance that a second. So let's go back to our first item. Let's make that go back to spawning in the very center of the screen. And then 1 second after the first asteroid, let's spawn 2 asteroids at the same moment in time. But let's have one of them be 100 pixels to the left of the center and 100 pixels to the right of the center.
And let's change them from enemy interceptors over to asteroids.
Okay. As a matter of fact, I'd forgotten. I was contemplating making them all asteroids, but we can leave different types in to show a more interesting combination of things. So there's one enemy centered on the screen, and then 2 asteroids that spawn very shortly after him, spaced out.
Excellent.
Alright, let's see.
So let's try something like this. Let's set the time cursor ahead 5 seconds after that, or 4 seconds. Let's put a very noticeable delay in.
Okay.
And now grab the 2 add items and paste them twice so that we have 4 items now created. And then just offset them 50 apart.
So 50 additional, so 150, 150.
So we got minus, let's say minus 100, minus...
We could even do this. This would make it a little bit easier. To the left 100, to the left 150,
Ooh, yeah.
To the right 100, to the right 150.
That sounds good. So now we know we've waited 4 seconds. So there should be a noticeable gap. But do one more thing for me. Change the outermost ones to have a different speed.
All right, let's bump them up by 1. Let's have them a speed of 3 instead of 2.
Okay, that should be a noticeable difference in the playback of our level. So our ship, 2 asteroids, and here comes different speed asteroids. Yep.
So now we can start to make patterns not only of position offset timing, we can also do interesting patterns by differing speeds.
Now let's have it pause 2 seconds and just spawn 2 more asteroids, but let's have them moving at an angle other than, or direction other than straight down, at an angle.
Okay, so we're advancing time 2 more seconds, and I'm going to just copy whatever would be a very convenient instruction. Let's grab our original add item line, but here we want to add an asteroid. Now let's begin with the asteroid from the left. As a matter of fact, let's have the leftmost asteroid actually spawn in from the far left of the screen. So let's give him a position X of 0. We can leave his speed. Actually, I'm going to bump his speed up to 3. And now let's take a look at that overload, the second overload that takes in a direction. Let's make a new direction so that he can move diagonally. So basically have some value in both X and Y on our direction vector. So we'll make a new vector 2. He is going to be on the left side of the screen, so let's have him move in the positive X, or 1 in X. And then move 1 in Y so that he moves down screen. Now one thing I do want to keep in mind is that the fact that we always want our direction to be a unit vector. And here with the value of 1 and 1, we actually have a length of greater than 1. So we should renormalize this to maintain the idea of the unit vector based direction. To accomplish that, I'll simply run this through the call to vector2.normalize, and that should take care of automatically wrapping that back down into a unit vector. Now, even though this is only one of the two that I wish to create, let's test and make sure that, I don't know, I'm now starting to contemplate because we have an amount of time we have to play through to get all the way down to 2.
So put the second one in.
So we'll just try it and see how it works. The second asteroid should spawn at the right-hand side of the screen and then move diagonally left. So the right side of the screen is going to be the full width of the screen. We can grab that by looking into config and grabbing screen width. And the direction we would like would be a negative X, so he moves left across the screen.
Mm-hmm.
All right, let's give this a try. There's our first enemy. 2 asteroids following him. 4 seconds goes by, and then 4 more asteroids at varying speeds. Fun.
Hey.
2 more seconds, and then 2 more asteroids cross through the screen, and there we go. So now we have tested things like item type, the positioning, the speed, possible direction modifications, and have messed around with advancing time.
Now, before we do much more with the level or even jump into stress testing, etc., go ahead and give them a quick show of what would happen if they did not maintain that item index.
You mean what would happen if we had
If it
changed?
reset back to 0 every time.
So if we simply forgot to move forward in that list.
Yeah.
If we were to leave this at 0, which essentially just leaves the loop starting as a standard for loop, starting at 0 and going through the whole list, that in mind might not seem like such a bad idea. It's like, okay, it'll be a little less efficient. It'll go through all the old items before it finds new items to spawn. But be careful. There are no further checks decided except to not spawn items in the future. Items in the past are always spawned, because if it sees an item in the past, it thinks, oh, this item is late. I'd better spawn it just like an item that's set for now. If we never advance from those old items, we'll actually keep respawning those old items over and over again every single game tick. So that means if I take out our call that advances our item index and rerun.
Cool.
That is, aside
Look
from...
at the nodes.
Yeah, look at our node count. We're getting up into the thousands, and we have crested 2,000. And there we go. Now we have peaked at 2,749 nodes.
Very cool looking image, too.
While it looks like we are drawing a Hall of Mirrors artifact, keep in mind that every single slice of graphic you see here is an actual game node that is being calculated by our game. As a matter of fact, I can show that a little bit by attempting to respawn the ship and noting that every time I try, we immediately explode because we collide with what could very well be 50 game nodes in that small area of screen space alone. So while it is definitely interesting, it is also definitely undesirable.
Right.
So once again, that's the danger in not advancing in the item index. So if we advance, it means we never respawn any item twice. We simply progress forward through time. Once again, giving the desired result of 1 item per spawn item instruction, or rather add item.
All right, so now let's do a stress test. Let's see what happens if we had 100,000 records being stored in that static list.
And this stress test is really key to prove the usefulness of the whole level item playback over time idea. And that is one of the things we had mentioned at the very beginning of the level discussion, was that we would like to have a lot of items that can be progressed through time, but we don't want them to be all calculated by the game engine at once. So to give an idea of this, let's pick a number that would pretty much crush the engine. 100,000 items. That would bring the game to beyond just a crawl. It would probably appear to be locked. Now, how can we quickly add 100,000 calls to add item? Well, let's use a loop. If we establish, and once we get this in place, let me explain where I'm going with this also. I want to have this set up to where each of these items we add are positioned randomly. So after our structured pattern of enemies and items goes by, let's make it look like random items begin to rain down from beyond the screen.
Okay.
So I'll make a for loop, and let's bring up the code completion template and change our length to a value of 100,000.
Okay.
So that should be plenty of items for use. Now, as I was saying a second ago, I would like these items to be spawned in random positions, and we'll need a random object in order to accomplish that. We'll instantiate the random object here as a local variable, and let's finish that off. We don't need to worry about seed for the random. Now, inside of the loop itself, we're going to need to remember to advance the time cursor, because if we put 100,000 items into the level items list and leave their time the same, that means we'll hit one game tick where we try to spawn 100,000 items at one time, thereby defeating the purpose of level.
Right.
So we're going to need to make sure we remember to advance our time cursor. As a matter of fact, instead of advancing it by 1, which would be 1 second, I'm going to do plus equals 1, and that makes the value more obvious for later tweaking. Now that we have everything set up, we are now free to start adding in our call to add item. As far as an item type, I will begin this. I'll begin this as a hard-coded to asteroid. I do want to show one neat trick after we get this in place, whereby we can auto-select a random item without having to do any type of if statement checks. And once again, for the position, I had mentioned that I wanted this to be random as well. So for position X, we'll get a random value within the range of the full screen width. So we can look into random, make a call to next, and then for the max value, we can specify config.screenWidth. So now we'll spawn for the full range of the screen. Finally, we need speed, which I'm simply going to give as 3. We could randomize this also if we would like. Alright, we're going to build, and now when we test this, 2 key things to keep in mind. We want to make sure that there is no significant slowdown at level startup, because again, we are spawning 100,000 things. And also we want to make sure that the level progresses smoothly. So if we run, well, there wasn't really any noticeable slowdown. And let's give the sequence a few seconds to play through until we get to the random section.
Looks like we're there.
But we can see now that asteroids are beginning to rain down from the screen, and the only place those instructions could be coming from are the beginning of the 100,000 instructions to play through. So this doesn't seem to be impacting performance at all.
No.
So we have just given ourselves the capacity to have at least 100,000 items in a level, and the engine handles things beautifully. One final thing I want to point out, and this can also be useful for testing, is you begin to gain more and more game items for use. And that is we can actually cast an integer over to an item type, and that allows us to select the item type randomly. Because, of course, random can come up with a number. If that's casted over to item type, we can feed that over to add item. So we're going to cast to item type the result of random.next, and we'll feed in a value of 2. With the upper limit 2, that gives a possible list of values of 0 or 1. And if we look at our enumeration, these individual items should be starting out at 0 and progressing on.
That's right.
So if 0 for asteroid, 1 for enemy interceptor, we can test this, give ourselves a few seconds to play through the predefined sequence. And 2 more asteroids. There's the first random, and we're starting to have enemies spawned in along with our asteroids. So all that looking very nice. We have now actually given quite a bit of testing to our level system. We've proven that each of the specific calls or the parameters in add item work. We have proven that we can have an excessive number of game items in our level. So
I think we've accomplished everything we set out to do in this video.
Everything looks like it's working nicely.
For a simple system, it's very robust. And as we said at the beginning, we were keeping this simple. But if you think about it just a little bit, there's some very simple modifications that you can do that will allow you to jump forward to a certain point in time, or perhaps rewind. Just think about it. Apply some very simple logic, some very basic math, and that's all you need to do. With that, that is going to wrap up this video. Another thing it's also going to do is it's going to conclude Space Fighter, with the exception of some bonus videos. But again, all videos that come after this point are considered bonus videos. This was the engine pushed just a little bit beyond the idea of a simple engine that we were going to demonstrate how to put together. We now have a 2D top-down scrolling engine that supports enemies, multiple players with textures that change out, a weapon system that's fairly robust, and now we have the ability to define levels. So from here, we'd like to start taking a peek at how we can do things like power-ups and attachments and maybe some heat-seeking type missiles. But again, these are all bonus elements that we're adding into XNA Volume 3. So, thank you guys very much, and we'll see you in the next video.